Mobile Application Development for IoT Unit-1 Material. Syllabus. Setting up your workspace, hardware and software requirements, installing Java Development Kit, installing Android Studio, setting up the Android Software Development Kit, hardware configuration, learning to use aREST library, creating your first Android project. Wi-Fi remote security camera, hardware and software requirements, Android phone sensor. Setting up your workspace. Project 1. Simple project with a relay module and a temperature and humidity sensor. Hardware requirements. The Arduino UNO board. The 5V relay module. The DHT11 or DHT22 sensor. 4.7K resistor. Small breadboard. Jumper wires. Note: all the above components are available in Amazon.in. Software requirements. Java Development Kit version 6 or higher. Android Studio. Android Software Development Kit. Android device with Bluetooth Smart Technology. Arduino IDE at http://arduino.cc/n/main/software. Library for DHT11 sensor, which can be found at https://github.com/otherfruit/dht-sensor-library. REST library found at https://github.com/marcoschwartz/aREST. To install a given library, simply extract the folder in your Arduino libraries folder, or create this folder if it doesn't exist yet. Installing Java Development Kit. Checking the JDK version. Open command prompt and type the following command. Java version. If Java not installed, download latest version of Java from Oracle website and install. Installing Android Studio. Go the Android developers website https://developer.android.com/studio and download the latest Android Studio. Open the downloaded file, and then go through the Android Studio Setup Wizard window to complete the installation process. The latest Software Development Kit, SDK, come pre-installed with the Android Studio install package. Select SDK Manager from Android Studio main toolbar, and install any packages that are needed by accepting the licenses and clicking on Install Packages. Setting up physical Android device for development. The following are the three main steps that need to be executed in order to enable your Android device for developer. Enable developer options on your specific Android device. Enable USB debugging. Entrust the computer with and installed IDE via secure USB debugging. Devices with Android 4th April 2002. 1. Enabling developer options. Depending on your device, this option might vary slightly, but from Android 4.2 and higher, the developer options screen is hidden by default. To make it available, go to the settings vertical bar about phone and tap on build number 7 times. You will find developer options enabled by returning to the previous screen or displaying a pop-up message. You are now a developer. On My Realme Mobile, Settings, About Phone, Version, Build Number. 2. Enabling USB debugging. USB debugging enables the IDE to communicate with the device via the USB port. This can be activated after enabling developer options and is done by checking the USB debugging options by navigating to Settings vertical bar Developer Options vertical bar Debugging vertical bar USB debugging. On my Realme mobile, Settings, System, Developer Options, Debugging, USB debugging. 3. Entrusting the computer with the installed IDE using secure USB debugging. Devices with Android 4th April 2002. We have to accept the RSA key on our phone or tablet before anything can flow between the device via Android Debug Bridge, ADB. This is done by connecting the device to the computer via a USB, which triggers a notification entitled, Enable USB Debugging. Check Always Allow from this computer followed by clicking on OK. Note, when I enable USB debugging in my Realme mobile, it asked confirmation, Enable USB debugging, select Yes. The computer's RSA key fingerprint is F7, B3, 0B, 9A, -- Enable Always Allow from this computer, and then click Allow, will be asked only first time. Hardware configuration. The following image summarizes the hardware connections with DHT sensor on the left of the breadboard, and the relay module on the right. Switch P-1, connect the power supply. The voltage common collector, VCC, pin goes to the red power rail on the breadboard, and the ground, GND, pin goes to the blue power rail. Switch P-2, connect the data pin to the pin number 7 of the Arduino board. Switch P-3, place the 4.7 ohm resistor between the VCC and the data pin of the sensor. Switch P-4, for the relay module, connect the VCC pin to the red power rail on the breadboard, GND to the blue power rail, and signal, SIG, pin to Arduino pin 8. Switch P-5, for DHT11 sensor, connect pin number 1 to VCC, pin number 2 to data, pin number 3 to NC and pin number 4 to GND. The following is an image of the completely assembled project. Using aREST library. The aREST library will allow us to simply control the Arduino board externally using the same commands, whether it is using an USB cable, Bluetooth, or Wi-Fi. The complete documentation on the aREST library is available at https://github.com/marcoschwartz/aREST. Arduino IDE. The main window of the Arduino IDE is where we enter the code to program the Arduino board. Arduino code files are called sketches. The following screenshot is of the Arduino IDE with the code. We basically use two buttons that you can find on the left-hand side of the toolbar. The first one, with the check sign, can be used to compile the code. The second one will be used to upload the code to the Arduino board. Note, if the code has not been compiled yet, the upload button will also compile the code before uploading. The second important window of the Arduino IDE is called the serial monitor, where we can monitor what our Arduino project is doing. By using the serial.print statements in the code to generate debug output, we can access it by clicking on the top right icon of the Arduino IDE main window. The following screenshot shows what the serial monitor looks like. Arduino sketch for the project. Libraries. The Arduino sketch starts by importing the required libraries for the project. #include aREST.h #include DHT.h DHT sensor Define on which pin the DHT11 sensor is connected to and which is the type of the sensor. Define pin 7. Define DHT-TYPE DHT11. Create aREST instance. aREST REST is equal to aREST. Create an instance of DHT11 sensor so that we can measure data from it. DHT pin, DHT-TYPE. Create two variables that will contain our measurements. Int temperature, int humidity. Void setup, void. Start serial port, with 115200 as the baud rate. Serial.begin, 1,15,200. Expose our two measurement variables so that we can access them via the serial port using the aREST library. Pass references, not values. Rest.variable, temperature, comma and temperature. Rest.variable, humidity, comma and humidity. Give ID and name to our project. Rest.set_ID, 001. Rest.set_name, Arduino_project. Start DHT11 sensor. DHT.begin. Void loop. Measure from DHT11 sensor, and convert these measurements to integers, as aREST library support only integers. Float h is equal to dht.read humidity. Float t is equal to dht.read temperature. Temperature is equal to int t. Humidity is equal to int h. Handle any requests coming from the outside. Rest.handle, serial. aREST library commands. Command. Output. ID. ID, 001, name, Arduino_project, connected, true. Mode 8.0. Message, pin D8 set to output, ID, 001, name, Arduino_project, connected, true. Digital 8.1. Activate the relay. Digital 8.0. Switch off the relay. Temperature. Temperature, 28, ID, 001, name, Arduino_project. Connected, true. Humidity. Humidity, 35, ID, 001, name, Arduino_project. Connected, true. Creating first Android project. Switch P-1, click on New Project when Android Studio launches. Switch P-2, select Phone and Tablet, Template and then select Empty Activity, and then click on Next. Switch P-3, give name, package name. Select Save Location, and Java as language. Select minimum SDK and then click on Finish. Switch P-4, select Tools, AVD Manager, create device and create a virtual device on emulator, e.g., Pixel 4 API 33. Switch P-5, select the virtual device on which we want to run the application and click on Play button. Switch P-6, we may connect a physical device using USB cable and select the physical device, e.g., Realme RMX3085, and click on Play button. The output will be displayed as shown below. Project 2, Wi-Fi Remote Security Camera. Hardware requirements. The Wi-Fi remote security camera project is based around the Arduino Uno board. The Arduino Uno is a powerful Arduino board with integrated Wi-Fi and an onboard Linux machine based on a very small Linux distribution called OpenWRT. It also has a USB port so that you can connect hard drives, cameras, or other USB devices. The following is an image shows Arduino Uno board. A USB camera to stream live video with the Uno, compatible with USB video class. A micro USB cable to power the Uno. A micro SD card to save the recorded data, optional. Software requirements, Arduino Uno. Install PuTTY or OpenSSH software to get a terminal. Type the command, ssh root at your uname.local, name given during configuring Uno board. Enter the password. Password is defined during the Uno's configuration step. Type the command, update, to update the list of available packages. Type the command, install Mod Video of MJPG Streamer. Hardware configuration. Switch P-1. Insert the formatted microSD card into the Arduino Uno SD card reader as shown in the following screenshot. Switch P-2. Connect the USB camera to the host USB port of the Uno, as shown in the following screenshot. Switch P-3. Connect the board to power via the micro USB port. Setting up video streaming. Switch P-1. Log into your Arduino Uno using the following command, ssh root at your uname. Switch P-2. Type the command, mjpg_streamer input of dev video 0r640x480f25, output http://p8080 www webcam, and start the streaming at resolution of 640x480, at 25 frames per second, on the 8080 port. Switch P-3, go to web browser and type your uname.local, 8080, which will open the main streaming interface. Switch P-4, to access the Steam itself for a test, go to http://arduinoune.local, 8080 stream.html. Live streaming coming from Arduino Uno to PC. Implementing a full-screen stream player on Android. Switch P-1, switch on the Auto Import function within your Android preferences. File, Settings, Editor, Auto Import. Switch P-2, create a new project with the following setup. Name, Android Uno Security. Minimum SDK, 15. Project, empty activity. Activity name, stream activity. Switch P-3, create 3 Java classes. Stream activity, the main activity that is created upon the start of a new project. MJPEG input stream. MJPEG view. To create a new class, you will need to go to app, src, main. Java, com.domainofyourchoice.android security. Right-click on the package name and select New, Java class and give the specific class name. Switch P-4, add the following code below the package name in Android manifest.xml file. Uses permission Android, name is equal to android.permission.internet. Uses permission Android, name is equal to android.permission.access_Wi-Fi_state. At these lines of code below, manifest, tag. Important packages used in mjpegview.java class. Package android.context.context. Public abstract class context extends object. This is an abstract class whose implementation is provided by the Android system. It allows access to application-specific resources and classes, as well as calls for application-level operations such as launching activities, broadcasting and receiving intents, etc. Package android.graphics.bitmap. Public final class bitmap extends object implements parseable. A bitmap is a digital image composed of a matrix of dots. When viewed at 100%, each dot corresponds to an individual pixel on a display. In a standard bitmap image, each dot can be assigned a different color. Package android.util.attribute-set. Public interface attribute set. This interface provides an efficient mechanism for retrieving data from compiled XML files. Package android.view.surfaceHolder. Public interface surfaceHolder. This interface allows you to control the surface size and format, edit the pixels in the surface, and monitor changes to the surface. This interface is typically available through the SurfaceView class. Package android.view.surfaceView. Public class SurfaceView extends view. Provides a dedicated drawing surface embedded inside of a view hierarchy. You can control the format of this surface and its size. The surface view takes care of placing the surface at the correct location on the screen. Public static interface surfaceHolder.callback. A client may implement this interface to receive information about changes to the surface. Code snapshot from mjpegview.java. Package in.co.gentuanantapur.arduino security. Import android.content.context. Import android.graphics.bitmap. Import android.util.attribute-set. Import android.view.surfaceHolder. Import android.view.surfaceView. Public class mjpegview extends SurfaceView implements surfaceHolder.callback. Public class mjpegviewThread extends thread. Public mjpegviewThread, surfaceHolder, context. Private void init, context. Public void run. Public void set surface size, int width, int height. Private bitmap makefs overlay, paint p, string text. Public void start playback. Public void stop playback. Public mjpegview, context, attribute set attributes. Public mjpegview, context. Public void surface created, surfaceHolder. Public void surface changed, surfaceHolder, int f, int w, int h. Public void surface destroyed, surfaceHolder. Public void showfs, boolean b. Public void set source, mjpeg input stream source. Public void set overlay paint p. Public void set overlay text color, int c. Public void set overlay background color, int c. Public void set overlay position, int p. Public void set display mode, int s. Important packages used in mjpeg input stream.java class. Package java.io.data input stream. Public class data input stream extends filter input stream implements data input. A data input stream lets an application read primitive Java data types from an underlying input stream in a machine-independent way. An application uses a data output stream to write data that can later be read by a data input stream. Code snapshot from JPEG input stream.java. Package in.co.gentuanantapur.arduino insecurity. Import java.io. Data input stream. Import java.io. Exception. Public class JPEG input stream extends data input stream. Public JPEG input stream in. Private int get end of seconds, data input stream in, byte, sequence, throws IO exception. Private int get start of sequence, data input stream in, byte, sequence, throws IO exception. Private int parse content length, byte, header bytes, throws IO exception, number format exception. Public bitmap read JPEG frame, throws IO exception. Important packages used in streamActivity.java class. Package Android.os.async task, params, progress, result. Public abstract class async task extends object. Async task was intended to enable proper and easy use of the UI thread. Package Android.os.bundle. Public final class bundle extends base bundle implements clonable, parcelable. Bundle is a utility class that lets you store a set of name-value pairs. You will always find this import along with the import for activity class because both onCreate and onFreeze methods take bundle as a parameter. Into a bundle object, you can put integers, longs, strings, arrays, etc. along with the keys to identify them. When needed, these values can be obtained by using those keys. Package Android.util.log. Public final class log extends object. This class allows you to log messages categorized based severity. Each type of logging message has its own message. Package Android.view.window. Public abstract class window extends object. Abstract base class for a top-level window look and behavior policy. An instance of this class should be used as the top-level view added to the window manager. It provides standard UI policies such as the background, title area, default key processing, etc. Package Android.view.window manager. Public interface window manager implements view manager. The interface that apps use to talk to the window manager. Each window manager instance is bound to a display. Package organization.apache.http response. Public interface HTTP response extends HTTP message. After receiving and interpreting a request message, a server responds with an HTTP response message. Package javanet.ori. Public final class ORI extends object implements comparable, ORI, serializable. Represents a uniform resource identifier, ORI, reference. Code for streamActivity.java. Package com.example.lalita.me application. Import android.app.activity. Import android.os.async task. Import android.os.bundle. Import android.util.log. Import android.view.window. Import android.view.window manager. Import organization.apache.http response. Import organization.apache.http.client protocol exception. Import organization.apache.http.client.methods.http get. Import organization.apache.http.impl.client.default HTTP client. Import java.io.io exception. Import java.net.ori. Public class stream activity extends activity. Private static final string tag is equal to MJPEG activity. Private MJPEG view MV. Public void on create bundle saved instance state. Super.on create saved instance state. Sample public cam. String URL is equal to http 10.0.1.6 8080. Action is equal to stream. Request window feature window.feature_no_title. Get window set flags window manager.layout params.flag_full screen. Window manager.layout params.flag_full screen. MV is equal to new MJPEG view. This. Set content view MV. New do read. Execute URL. Public void on pause. Super.on pause. MV.stop playback. Public class do read extends async task. String void MJPEG input stream. Protected MJPEG input stream do in background. String URL. To do, if camera has authentication, deal with it and don't just not work. HTTP response raise is equal to null. Default HTTP client is equal to new default HTTP client. Log.d tag 1. Sending HTTP request. Try. Raise is equal to client.execute new HTTP get ori.create URL 0. Log.d tag 2. Request finished. Status is equal to plus raise.get status line .get status code. If raise.get status line .get status code is equal to 401. You must turn off camera user access control before this will work. Return null. Return new MJPEG input stream raise.get entity .get content. HTTP response raise is equal to null. Default HTTP client is equal to new default HTTP client. Log.d tag 1. Sending HTTP request. Try. Raise is equal to client.execute new HTTP get ori.create URL 0. Log.d tag 2. Request finished. Status is equal to plus raise.get status line .get status code. If raise.get status line .get status code is equal to 401. You must turn off camera user access control before this will work. Return null. Return new MJPEG input stream raise.get entity .get content. Catch client protocol exception e.print stack trace. Log.d tag request failed client protocol exception error connecting to camera. Catch IO exception e.print stack trace. Log.d tag request failed IO exception error connecting to camera. Return null. Protected void on post execute MJPEG input stream result. mv.set source result. mv.set display mode MJPEG view.size_best_fit. mv.show fps true.